You've probably seen a million different SAT Desmos videos online before, but one thing that you're probably not as familiar with is when do you actually use Desmos and when do you not use Desmos on the SAT? I've had so many students ask me this question. I've had many students even tell me that they're really, really good at Desmos. Chances are they probably aren't even that. But they tell me that the one issue that they do have is that they just cannot figure out when to use it versus when not to. And this is honestly really a big thing because many of you also have not actually learned Desmos ever before in your life. Like, I'm sure many of your math classes never used Desmos once. I was a little bit fortunate back in high school. Some of my math classes actually did involve Desmos a bit. My teachers actually told me, hey, you should use this thing. It's actually like really good. But many students are not in that position. So this may be the first time you've ever even learned how to use Desmos at all on the SAT. And now you have to figure out when to use it and when to just go back to your regular methods. Now, the thing is, I'm not just going to give you a list of different things on which problems involve Desmos and which do not. Okay, I will give you one list at the end of this video. But before I do that, the truth is you have to understand a simple truth about how to think about Desmos on the SAT. Because here's the thing, many students look at it like this. Many students believe that there are some problems on the SAT that are just Desmos problems. These are problems that you should always use Desmos for. If you're not using Desmos for them, you're bad. You're going to do bad on the SAT. You're going to waste so much time. And then there are just some problems that are not Desmos problems, non-Desmos. And you should never use Desmos on these problems. If you ever do, you're really bad. You're going to fail and it's going to be really terrible. And you're just going to waste a bunch of time. Truth is, this is not a really good way to look at it because I want you to think about this. The SAT, throughout all of its existence, has always been focused around two specific things. And this is true for every single SAT, both the digital SAT, the paper SAT, if you're taking the SAT in the 70s, if you're taking it like today, there are two things that always are going to lead to a higher score. First is accuracy, and second is speed. Just these two things. If you can have super high accuracy on every single SAT question, you're probably going to get a good score. If you can have super high speed and also pretty high accuracy, you also are likely to get a good score. If you can max out both of these, then you're guaranteed to get a 1600 every single time, if you are literally at the max of both of these. And so, all we are thinking about whenever you're thinking about anything for the SAT, whether it's Desmos or any other method, any other technique, anything, we're always just thinking, is it going to either maximize our accuracy or maximize our speed? That's always the exact same question we ask ourselves. And if it does do either of these two things, if it maxes accuracy or speed, then yes, let's go for it. Let's use it. Let's use it whenever we can if it's doing those two things. If it doesn't, though, of course, we should not use it. We should not use methods that are bad, that don't allow us to solve the problems, that don't allow us to do them faster. And this is how we should always be thinking about this. And so this is the same way you should think about Desmos as well. You shouldn't think about it like there's some problems that involve Desmos and some that just do not involve Desmos. Rather, it's the case that you're solving these math problems just like you always have been. You know, do step 1 in the math problem, do step 2 in the math problem, do step 3. But now you're just thinking to yourself, if one of these steps can be made either faster or better using Desmos, I should use it for that instead. So if step 1 can be made faster with Desmos, I should use it. If step 3 can be made faster with Desmos, I should use it. If step 2 does not involve Desmos at all and should not involve Desmos, then I should not use it. Obviously, it should just be done by hand. And so that's how I view every single time I look at an SAT math problem. I always think to myself, each of these steps, can I use Desmos for it? If yes, I do. If no, I don't. I'm not like thinking to myself some kind of algorithm about like this problem has this exact thing and so I therefore should use Desmos because it has that thing in it. And if it didn't have that thing in it, I would never use Desmos. I never really do that. And it probably something that you're thinking about right now as I say this is that there's a very, very good analogy that you can think about with this exact thing, which is AI. Many times throughout the existence of AI, companies, people have just thought to themselves, if I use AI, it's going to be a good thing. It's going to be beneficial. If I make a product, that's fine. But if I make a product with AI, it's better. If I make a song, that's fine. But if I make a song with AI, it's better. If I'm doing some project for school, if I don't use AI, that's bad. But if I do use AI, it'd be good. But don't use that as advice. I'm not recommending to use AI on school projects. But of course, we don't care about this. Like, who among us looks at restaurants that they want to go to and thinks to themselves, oh, I should only go to a restaurant that is sponsored by AI? Or who looks at songs they want to listen to and thinks to themselves, I should definitely listen to a song that's made by AI? Nobody does that. In actuality, you should only be using AI when it makes your life easier or better. Same thing as this, accuracy or speed. If AI makes things easier or better, I should use it. If it doesn't make things easier or better, I should not. If I'm writing an email for work and there's no reason why AI would do it any worse than me, I should just use AI. There's no reason not to. But if I'm like trying to make food or something, obviously I can't use AI for that. And if I just try to insert AI into it somehow, it probably would not end up that good. If I was trying to make music and I just use AI for every single thing, it's probably not going to sound that great. It's probably going to sound kind of cringe. People are going to call it AI slop. Same thing with AI YouTube videos, all these different things. You're always just thinking, is it going to be made better by using AI? If the answer is yes, you do. If the answer is no, you don't. And so that's the same thing with Desmos. And so let me give you some examples of this. In these problems, I'm going to solve every single step of it. And if a step could be made better with Desmos, I'm going to use Desmos on that step. If it could not be made better with Desmos, I'm not going to use Desmos on the step. So this equation is true for all of this, where A and B are positive constants. What is the value of AB? Probably the first step of this problem is I just need to write out the equation so I can actually see it. Desmos could be used for that step, so I should probably do that. Okay, that first step is done now. Okay, the second thing is we basically need to solve the equation. Now, if I was to do this by hand, it would take a lot of time and be really confusing. I have to do a bunch of algebra stuff to make it work. So again, I might as well just use Desmos because that makes it simpler and easier. So I can just go ahead and use regression. If you're not familiar how to use this, check out my other video on Desmos regression. I go all into this exact process what I'm doing right now. Okay, let me make a constraint. X1 is going to be equal to 6 ... 15. I would typically do 1 ... 10, but we can't have 5 in the thing, so I might as well just do that. And then we have these here. So A and B are positive constants. Yep, that is true as well. A times B would be 1.36. So therefore 1.36 should be the answer for this problem. Okay, so now we've solved the equation. We have A equal to that, B equals to that. All I have to do for the third step is just multiply together what A and B are. Obviously, that's made a lot easier and faster with Desmos, so I should just go ahead and do that. A times B, 1.36. Yes, so that would be the answer. You can see here, I wasn't thinking at all in this problem that this is just a Desmos problem, that I should just use Desmos on this entire problem. I was just looking at each step and thinking to myself, could this be made better with Desmos? And if yes, I do it. Second thing here, quadratic has the vertex this and one x-intercept at that. What is the other x-intercept? So probably the easiest way I could start out with this problem is just writing out the function in some way. Now, if I was to do this by hand, I would have to write it all out on a piece of paper. It'd be really hard, really cumbersome, and I also cannot really show it in this video. So I might as well use Desmos for that as well. So let me do table and just do -2, 5, and then 4, 0. And then let me make it into this and do a quadratic. Okay, that's fair. So step 2 would just be making sure that this function actually matches up. Now, I go back to Desmos because I kind of have to for this step because we already are kind of locked in at this point. But if we look at this now, we see here that 2, -1.67. -2, 5 is supposed to be the vertex, not 2, -1.67. So instead, I should go ahead and put this into regression form. So I can do that, x1 minus, I guess, +2 squared, and then +5. Okay, yes, now we see it does work. -2, 5 would be the vertex, and 4, 0 would be the x-intercept. Last thing we just need to do here is just find where the other x-intercept would be. And we see it's -8. So that the answer is just -8, 0. Again, same kind of thing. I did use Desmos for every single step of this problem, but it's not because I said this was a Desmos problem. I just checked to see, could I use Desmos for each step? Now, one more thing. I want to show this is usable in other types of problems as well. So we have this geometry problem here. Right triangle this. The altitude is that, and yeah. So they give us all this information. The first thing I need to do in this problem is probably just write out the information. Like, I can't do this if I don't actually have it written out. Can I use Desmos for that? No, I cannot use Desmos to write out a triangle. Unfortunately, maybe in a future version of Desmos we can do that, but I cannot use Desmos. So therefore, I'm not going to be using Desmos for this step. So I'm just going to write it out here instead. So E is the right angle, and then the altitude from that goes to here, and it meets at that point G. And then we have basically here DG is equal to 6, GF is equal to 54. And then we have an altitude going there. So yeah, what would be the second step of this problem? Well, probably the easiest thing I can do now is find out what EG would have to be. What is this altitude? So that'd be step 2, and I can probably write an equation for that, so I probably could use Desmos to make that step a bit easier. One good equation you can know is that the altitude is always equal to the square root of these two pieces. So square root of 6 times 54 would be 18. If you don't know that equation, definitely check out my full course, Mission 400 Plus. It goes through that and a bunch of other stuff as well. Okay, so 18 there, and then next step of this problem probably would just be find out what the other sides have to be. Pretty simple, not really too much else I have to do, so I can probably do that with a Pythagorean theorem. Now, Pythagorean theorem, that is also something I can use Desmos for, so I might as well just use Desmos for that. So Pythagorean theorem on this first one be 18 squared plus 54 squared tilde c squared. So yeah, 56.921. Second one, 18 and 6. So I just do 18 squared plus 6 squared tilde c squared. 18.97. Okay, now that I have the other sides, I can just go ahead and find the answer just by doing the regular tangent stuff. Again, this could be made easier by using Desmos, so I might as well do that. So tangent of that would be equal to 56.921 divided by whatever this is. So drop that in there. Okay, we basically get 3. We're trying to see, definitely is showing you here that's supposed to be 3. It just is not able to show that many numbers. So that's done, and the answer to this one should be 3. Now, this one was a little bit different from the other ones. The first step was not, we did not need Desmos for that. Meanwhile, steps 2, 3, and 4 all were made easier or better by using Desmos. Okay, as promised, I will give you just a short list. So I know, despite everything I just said in this video, you probably do kind of crave some kind of basic explanation as for when you use Desmos, when you don't. So I might as well fulfill that desire and give you one. So I have this list that is actually in Mission 400 Plus, but I'll just give it to you for free. And it just shows these are the 5 different categories of things where you should use Desmos or not use Desmos. So you should use Desmos algebra whenever something like a single variable equation, system of equations, anything involving inequalities. So anything like x plus 3 equals 5, we can pretty easily just use Desmos for that. Or we could say if it's like greater than 5, or if it's like a system of equation, we have like something here, 2x plus 3 is equal to y, like something like that, we can always use Desmos for it. Now, if an equation has more unknowns than equations, then algebra alone can solve. You have to use regression without a table. I won't even try to talk about this one. I have a whole video on this, so you might as well just watch that. If you still do not know what Desmos regression is, I'm not going to be able to explain it just in this video alone. So just save it for that video. Third thing, regression with a table. This is for when you're given points and you need to find a function that connects them. So kind of like in this problem over here, we're given 2 separate points and then we had to figure out what was the quadratic that goes with them. So that's when we use regression with a table. Anything like that. If you see points, automatically know regression. 4, other Desmos things. So these are just a bunch of other random things I talked about in my other videos and in the course and all that stuff. So if you see something like circles, factoring, statistics, trig, ratios, unit conversion, any of this other stuff, you can just use other things in Desmos. For example, with circles, you can write out the circle thing in Desmos and use the midpoint function or the distance function. Or factoring, you can just see, does the thing that's being a factor, the bigger one, have the same x-intercept? And then finally, everything else you can just do by hand. So a bunch of things here, algebraic manipulation. So something like if I was trying to add something to the other side, like if I had 2x plus 3 is equal to 5, and for some reason I can't just put this in Desmos, I can subtract 3 from both sides. I have to do that by hand. I can't use Desmos for that. Geometry, just like I did over here, you cannot put different shapes into Desmos, so you have to do that by hand as well. Interpreting word problems, that's obviously all on you, all on your brain. You have to just use your brain to figure out how to figure out word problems. One more thing, I am going to have a new Desmos video on the channel very, very soon. I actually am making it my goal to upload a new video on the channel every single day of July. And so one of them hopefully will be a new Desmos video. But until then, I have this here, all of SAT Desmos in 35 minutes. This is on my other YouTube channel. I'll drop it in the link in the description below. This is a really good video, only 35 minutes of your time, and it pretty much goes over everything involving SAT Desmos. I would really, really recommend watching this because all the stuff that I explained in this video is all covered in this video already. Now, of course, if you want more help with this, you can definitely check out Mission 1400 Plus with the link in the description below. We have a bunch of resources in here, plus we have a full course on Desmos specifically. So if you want Desmos information plus also practice problems, you can definitely reference this as well to get that. Plus we have a bunch of other resources in here, including a full credit leaderboard. This is basically a way to be rewarded for studying each day. It actually gives you rewards like the ones you see on the screen here for every single additional day you study. So you can actually get one-on-one tutoring with me plus a bunch of other really cool stuff. Anyways, that is it for me. I hope you enjoyed this video. Hope this was actually able to enlighten you on how to use Desmos, and I'll see you guys in the next one. Make sure to always stay Gucci.